Okay. Okay, so in order to solve an equation like this, so basically this is, wait, hold on a second. I just realized I think it's 3 cosine squared of w. Yeah, okay. So let me fix that last part of that. Okay, so since I have 2w in one cosine and w in the other, I need to use the double angle formula for on the left-hand side. The double angle formula, I want to use the one that involves cosine only. So that is, so the double angle formula for cosine, I'll do it in terms of w. Cosine of 2w, that's equal to, one way to write it is cosine squared of w minus sine squared of w. The other two ways to write it are based on replacing cosine squared with 1 minus sine squared. That's the Pythagorean identity. That would be 1 minus 2 sine squared of w. And then you could also replace sine squared with 1 minus cosine squared. And then you'd have 2 cosine squared w minus 1. All right, so I'm going to use the bottom one there. So I'm going to write, I still have the 3, and then I'm going to put that identity in parentheses. So that's 3 times 2 cosine squared w minus 1. And equals 3 cosine squared w minus 1. All right, now let's distribute that 3 through. So that just gives us 6 cosine squared w minus 3 equals 3 cosine squared w minus 1. Sometimes students like to change the cosines into of their own variable and solve for that and then go back. I like to manipulate the cosines themselves, but what I usually remember is if I only had an x squared in an equation but no x, I would isolate that. So what I'm going to do is I'm going to subtract the 3 cosine squared that are ink that I wanted, and that'll cancel it from that side. And then I'm going to add 3 to the right-hand side. And so let's see, now on the left I'll have 6 cosine squared minus 3 cosine squared will give me 3 cosine squared w on the left. And then on the right I'll have negative 1 plus 3 is 2. All right, now I'm going to divide by 3. And then I'm going to take the square root cosine of w equals, and remember when you take the square root to solve an equation, it could be the positive or the negative square root. Now, square root of 2/3 is not the cosine of a special angle. So I'm going to have to do this using the inverse cosine. Since it's plus or minus, I want the angle in all 4 quadrants. Cosine is positive in the first quadrant and fourth quadrant, negative in the second and third. But if it's the same cosine, it's going to have the same reference angle in all 4 quadrants. So I'm just going to do, I know one solution will come from w equals cosine inverse of the square root of 2/3. And now, let's pull up the calculator. And when we do that, once we get that, that'll be our first quadrant angle. And what I'll do is then I'll find the equivalent angle in the other 4 quadrants. I want to do radians here. When you're solving cosine equations, unless it's an applied situation, you almost always want to be in radians. So let's go.
That's what I was going to ask.
So now I'm going to do the cosine inverse of square root of 2/3. Looks good. Out, close parentheses, enter. So that's my first quadrant angle. And then now for my second quadrant angle, I'd subtract that from pi. So I do I do pi minus that answer. I don't know why I did that. What's up there? Minus. Try one more time. Pi minus, I keep hitting the wrong buttons on my calculator here. There we go. So that's my second quadrant angle. For my third quadrant angle, I might just, so I could do pi plus, and then maybe carry, I'll do we'll do 0.615, maybe 48. That's 5 decimal places is plenty. I know that whatever it asks for is less than that. And then for the last one, I would do 2 pi. In the fourth quadrant, I'd do 2 pi minus that 0.6154. And so you can see that all three of the solutions there, because 0.61548 was one of them. Rather than typing them in, I'll just, on mine, I think I can click show answer. And there's your 3 solutions, or 4 solutions, sorry. All right. So the main key for this one was at the very beginning, since I have a cosine of 2w, but my cosine squared is just of w, I needed to use the double angle formula for the cosine of 2w. Go back there for the tail end of that. There's the whole thing. All right, let's see here. We got a new, got Cassie. Hi, Cassie. How are you tonight?
All good.
Okay. Oh, you already put in a number for me. All right. So let's see here. So let's do Cassie's 156489, and I'll come back to Scott. 156489. There it is. All right. Okay. So this one. So when you have, so we got 7 and 2 pi over 3. So let's write that down. So that's polar coordinates. Was 7 and 2 pi over 3. Ooh. So basically, if you have a coterminal, if your angle is coterminal with 2 pi over 3, then you have the same point. It refers to the same point. So if I add 2 pi or 4 pi or 6 pi, or if I subtract 2 pi or 4 pi or 6 pi, I'm going to get the same thing. So 2 pi is 6 pi over 3. So a coterminal angle with this would be 2 pi over 3 plus 2 pi, which is 6 pi over 3. So I'm going to rewrite that as 6 pi over 3. So that would be 8 pi over 3. So one possibility would be 7 comma 8 pi over 3. That's another angle that's coterminal, or that's coincidental. So unlike with when you graph points on a plane, once you have a set of coordinates, it only describes points, a point, and there's no other set of coordinates that describe that point. Polar coordinates is different because the angles keep cycling around. I could also have done 2 pi over 3 minus 2 pi. That would be 2 pi over 3 minus 6 pi over 3. So that would be negative 4 pi over 3. So another point would be 7 and negative 4 pi over 3. Now, it's also the case, though, if you go half a circle away. So let me draw a picture for this one. In fact, I'll draw a picture of roughly where this is. So 2 pi over 3 is in the second quadrant. It's the equivalent of 120 degrees, so it'd be more towards the y-axis than the x-axis. So let's say that is 7 comma 2 pi over 3. So what 7, 8 pi over 3 is doing is just basically going one more rotation around, but you still end up on the same line, and the 7 tells you your distance from the origin. And the negative 4 pi over 3 is just going backwards one full rotation. Okay. But the other thing I could do is if I went exactly half a rotation away. Okay, actually, let's go in the positive direction. That'll be easier to see. Right, this point on the opposite side is 7 comma 5 pi over 3. Well, if I negate the 7, if you negate the r, it means basically just go the exact opposite direction. So if I change the 7 to a negative 7, but keep the 5 pi over 3, that's the same point. That's back to this point over here. So all 4 of these sets of coordinates refer to the same point. They're just different ways of getting there. So I mean, and it says that the second one has to be negative, but I can just, so the second one you could just subtract the pi, but so we had 7 comma, and then I did 8 pi over 3, close parentheses, right? And then for the second one, let's do the one with the -7. So -7 and 5 pi. This one, the reason I didn't just do a show answer on this one is because, as I'm sure you know, it'll just say answers vary. So there you go. So show answer, answers will vary. I may edit this question sometime to show possible answers are, or something like that. All right. So there's that question. Okay. Let me see Scott's question again. 149,358. 149,358. See a lot of 149s. There it is. Okay, so we're going to convert this r equals -6 cosine theta to a Cartesian equation. Okay, let's take a look at that. R equals -6 cosine theta. Okay, so what I remember in terms of doing this question, x equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. For this one, what I'm going to do is here I'm going to rewrite the x equation into cosine theta equals x over r. Just divided both sides by r. So I'm going to leave the r on the left side momentarily, and I'm going to change cosine theta into x over r. So I've got -6 times x over r. And then I'm just going to multiply both sides by r to cancel that r on the left in the denominator. So now I have r squared equals -6x. And now if you look on the right-hand side, I'm going to use r squared equals x squared plus y squared. And I'm going to write x squared plus y squared equals -6x. And I'm pretty sure it will let you leave it as that. This actually happens to be the equation of a circle. But it doesn't ask you that part of it. So let's see here. If we type that, x squared plus y squared equals -6x, it'll give us credit for that. But let's see. So what it did in this version is it converted it to the circle equation. And you don't have to do that, but just real quickly to show you what the idea of that is, we add the 6x to the left-hand side. So you have x squared plus 6x plus y squared equals 0. And then now I need to complete the square with the x squared plus 6x. That'd be x plus 3. It's half of it squared, and then the missing term is 9. So I add a 9 to both sides. So now the x squared plus 6x plus 9 is the x plus 3 squared plus y squared equals 9. So this equation turns into a circle with center -3, 0, and radius 3. So basically, the graph of this would look like that. Or that's -3. That's what the graph of r equals -6 cosine theta looks like. And please jump in if you have questions as I'm doing these. Jump in too. I know I see with the chat you guys are popping in questions, which is great. But stop me if I'm working on one of these and you have questions about it. All right. So 156,232. 6,232. There it is. Okay. So we have a sine value in the second quadrant, and we're looking for the sine, cosine, and tangent. All right, so sine is 2/3, x is in the second quadrant. So let's take a look at that. Sine of x equals 2/3, and where x is in the second quadrant, so you can sort of think that this is an angle. So let's draw a triangle in the second quadrant. There's x, and sine of x, you can also think we'll put x prime down there, that's the reference angle. Sine is opposite over hypotenuse. All right, so now I need to find the adjacent side. So I got a squared plus 2 squared equals 3 squared. A squared plus 4 equals 9. So a squared equals, subtract 4, that'll give me 5. And a equals the square, plus or minus the square root of 5. But since this is the x coordinate and it's to the left, it's going to be a negative square root of 5. Okay. So that's the adjacent side, or the horizontal side. Now I can just do my formula. Sine of 2x is equal to 2 sine x cosine x. And so let's see here. Sine x is 2 times, I'd have 2 times 2/3. And then the cosine is negative square root of 5/3. All right, and when I multiply that out, I'm going to have a negative. Let's see, 2 times 2/3 is 4/3, times negative 5/3 is negative 4 square root of 5 over 9. So once we get that horizontal side, which gives us cosine of x, I can even write the cosine at the top. Cosine of x equals negative square root of 5 over 3. I also could have used the Pythagorean identity there to find cosine x. Now, cosine squared, or sorry, cosine of 2x rather, cosine of 2x. Since I was given the cosine first, I'm just going to say it's 1 minus 2. I was given the sine first, sorry, 2 sine squared of x, which is 1 minus 2 times 2/3 squared. So that's 1 minus 2 times 4/9, which is 1 minus, 2 times 4/9 is 8/9. So that's 1/9. So the sine of 2x is negative 4 squared root of 5 over 9. The cosine of 2x is 1/9. And then tangent of 2x, there is a formula, but since I just found sine and cosine, I'm just going to say it's the sine of 2x over the cosine of 2x. So the sine of 2x was negative 4 square root of 5. I'm going to write it this way, with the over 9 that way, over 1/9. And when you're dividing ninths, you just basically divide the numerators. So the ninths cancel, and it's negative 4 square root of 5 over 1, or just negative 4 square root of 5. So let's just make sure. I closed the window apparently, so I won't. But that is the answer. I meant to just double check that to verify the answer. But I apparently closed the window. All right, 149,516. 149,516. All right, so we have a vector. It has magnitude of 10, and its angle is 25 degrees, and we want to put it in component form. So we got magnitude of v is 10, and the angle, the theta for v is 25 degrees. All right, so the horizontal is basically this is just like the x and y from r and theta when we were doing polar coordinates. So basically it's just, you can think of it as r cosine theta and r sine theta. R sine theta, where r is the magnitude of v. So the x is going to be 10 cosine of 25 degrees, and the y is going to be 10 sine of 25 degrees. And you just type those in your calculator, and it'll spit those out. We'll just verify with one of them. 10 as a cosine. My calculator's already in degree mode. So 9.912. If we go back, so that's the cosine one. That should be the x. Oh, wait a minute. Maybe I'm in, oh wait, did I win? I'm in radian mode. Oops, sorry. I thought it was in radian degree mode. Let's try again. 9.063, that looks better. All right, so that's, and then if you do 10 sine, that'll give you the, oh, and I didn't use the right braces. Remember, when you're doing vectors, The components of a vector go in the pointy parentheses. Those are, you can either use the math thing or they're over the comma and the period on your keyboard. All right, let's see. All right. 132471 from Cassie. 2471. There it is. All right, simplify this to a single trig function, sine of u minus pi over 2. So we're going to use the difference formula for sine. Sine of u minus pi over 2. Now, there's lots of formulas for this test. One thing I do, like let's take if I do the sine sum formula, sine, we'll call it x plus y. The inside variables don't matter. It's, I'm not going to have enough room here. Let me give myself a little more room. Sine of x plus y is sine of x cosine of y plus cosine of x sine of y. Right? I say sine cosine plus cosine sine. So basically, if you remember that, then for the subtraction formula, you just change the middle to a minus. For the double angle formula, they're both x. It's sine of 2x is x plus x. So you got sine x cosine x sine x, and that's where you get the formula we used just up above. So with the minus, sine of x minus y, that's sine x cosine y minus cosine x sine y. So let's see here, we got sine of u cosine of pi over 2 minus cosine of u sine of pi over 2. Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So the first term is 0, and the second term is negative cosine of u times 1. So it's just negative cosine of u is the answer. So if we go back here, show answer, negative cosine of u. That's okay, but it looks like at least you're understanding what I'm doing. So that's good. So let's see, 149315. There it is. Okay. Okay, so this one I'm going to just copy and paste the text. All right, so we got a pilot flies in a straight path for 1 hour and 30 minutes. She then makes a course correction heading 65 degrees to the right of her original course and flies for 2 hours, 15 minutes in the new direction. If she maintains a constant speed of 410 miles per hour, how far is she from her starting position? All right. So let's say north is her original direction, and then dotted line as if she had continued, and then it says 65 degrees to the right. It's a little longer that way. So this angle up here is 65 degrees, and we want to know how far she is from her original position. So call this length D. All right, well, if you remember your angles on a straight line, the inside angle of that triangle is 180 degrees minus 65 degrees, which would be 115 degrees. Now there's two ways to find D. Basically you can use the times as the lengths for the side. So I can do 1.5 for that length, 2.25, 2.25 hours for that length, for the top length, and find D in terms of the time and then multiply. But I'll just go ahead and do find the distances for each. So I'm going to do 1.5 times 410, which will be, let's see, 410 and half of 410. That would be 615. So the left side is 615. And then we've got 2 1/4 times 410 for that top side. 410 is not divisible by 4, so let's just real quick. It's going to be something 0.5 times 410. 922.5. Okay. So this is I like to use the law of sines anytime I can. Here's how you know if you can use the law of sines. You have an angle, and you know you have one angle with a side opposite that you know. In this case, the only angle I have, 115 degrees, is opposite a side I don't know. So I'm going to have to use this law of cosines to find d. So the law of cosines is one side squared equals the other two sides. Basically, I always think it starts off like the Pythagorean theorem. One side squared equals the sum of the other two sides squared. But then it's minus 2 BC sine A. So 2, 615 is 922.5 times cosine of 115 degrees. So I basically just put that right-hand side into my calculator and then take the square root. So let's see here. Let's go ahead and do that. 615 squared plus 922.5 squared minus 2 times 615 times 922.5 times cosine of 115 degrees. Enter. So remember that's d squared, so I need to do the square root of the answer. Oops. Hit enter. So it says to the nearest mile, so that was 1307. Go back to that problem. Show the answer, 1,307 miles. Okay. No worries. Hey, remember, I will post this video after the webinar, so anything you're asking, if other people have questions on them, it'll help them. All right, let's see here. I should actually copy your the ones you've asked for. 156492, so that I can then put those 156492. 6, there it is. It says 492. All right. Okay. So if we have a vector, we want any other vector that's orthogonal to A. That's not trivial. Okay. So orthogonal just means the two vectors form a 90-degree angle if they crossed or if they started at the same point. So let's write down that vector. My vector is 7, 2. So basically, the easiest way to do this, there's no single right answer, as the show answer will show you. Think of perpendicular lines. So if I have a slope, if m equals a over b, and I want the slope of a perpendicular, in fact, Cassie, I'm going to make you give me the answer to this. If the slope of one line is a over b, what would the slope of the perpendicular line be? Do you remember?
7 over 2?
Is it what?
7 over 2?
No. But a over b, in terms of a and b. If one line has a slope a over b. Oh, I don't care. We can do it in numbers. Let's say one line has a slope of 3/4. What's the slope of any line that's perpendicular to that?
Oh, 4/3. Oh, negative 3/4.
Negative 4/3. Not negative. Flip it and negate it. Both.
Okay.
3/4. So that's what you need to do here. But just be careful. So you reverse them, but you don't want to negate both of them. Right? Because what would happen if you had -4 over -3? You'd have positive 4/3. So you
Right.
only negate one of them. So, and it doesn't matter which one you negate. So if you could negate, you could negate the 2 or the 7. And what shows this to be true is two vectors are orthogonal. One way to show that they're orthogonal is that their dot product is 0. So if I did 7 times -2, product of the first components plus 2 times 7, well, I'd have -14 plus 14 is 0. So if I go back here, like I said, I could do either way. I could do 7 comma 2. Oops, what did I say? I actually should have this. I don't know why it's written this way. Right, 7 and 2. I should have a single answer box. Oops, I said -2. Oops, I've got them in the wrong order. Good grief. How about -2 and 7? So that'll work. So will 2 and -7. That's correct. If you doubled both of them, that would still work. I did 4 and -14. That's still correct. And the reason why is because that would be like a slope of 8/6. If I double both, that just reduces to 4/3, but it's still perpendicular. Okay? So, but the easiest thing to do is just reverse the order and change the sign of one of them.
Okay, perfect. Thank you.
You bet. All right. You're welcome for all the help. All right. Yeah. You write all those down so I don't forget them. Then when I send out an announcement when the recording is ready, then I can tell people what the questions were. All right. You're welcome, Scott. If you guys I'll be on here until 10 if you guys have any questions. So keep working. Come back and ask questions if any more pop up. Have a good night. I'll be on, but I'm just going to pause the share in my audio. Okay.
Sure.
Okay, so here's the question, my version of it anyways. Is your wind blowing from the north or from the south, east or west? Curiosity.
Let me check. This one says from southeast.
Okay, so I'll draw both pictures. So mine's from the northeast, yours is from the southeast. Because the pictures are a little different depending on whether the wind is blowing from behind the plane or in front of the plane.
Okay.
Okay. So here's our plane going north. So if the wind's blowing from the southeast, remember, so let's draw a little grid over here, north, east, south, west. So if the wind's blowing from the southeast, let's draw a dotted line, and then it'll push the plane to the northwest. So your triangle will look like that, right?
Okay.
But mine, the wind is blowing from the northeast, so the wind is coming this direction, and it'll push the plane back down to towards the southwest. So my unknown side, so then we would put the wind speed and the plane speed, so 600 for the plane speed, that's the line going due north, and then 80 for the wind speed. All right, but your example is slightly trickier because, so this angle right here is 45 degrees because southeast, northeast. If it says that, you can assume it's a perfect 45-degree angle from north or east or whatever.
Mm-hmm.
So then you need to use the angles on a straight line to get the angle inside the triangle being 135 degrees. Whereas on mine, the angle inside is just, I don't have to worry about angles on the line. It's just 45 degrees. Mm-hmm. So now you use the law of cosines exactly like we did on that other problem. So in your version, you would have, if we call let's see, there's two questions on there. There is how many degrees it is, which is, you actually find the speed first and then find the other angle second. So this is the angle at the bottom you want. That's west of north. Okay, so you would start off by doing d squared equals 80 squared plus 600 squared minus 2 times 80 times 600 times the cosine of 135. And the only difference for the one on the triangle on the right is instead of 135 degrees, it would be 45 degrees.
Okay.
All right, and so I'm going to do it for mine, just because that way we can compare the answers. So let's see, I'll have 3 squared plus 600 squared minus 2 times 80 times 600 times cosine of mine was 45. All right, and then I'm going to take the square root of that. So I have 546, and it makes sense that since the one is blowing from the northeast, that it's slowing the plane down. So it makes sense. So the speed on the other one would be higher. So I got, let me, 546. I'm going to say 546.38, so that when I find my angle, I don't get a rounding error. Okay. Now, for the angle at the bottom, I'm going to use the law of sines. Now, I always use the law of sines if I can. And with the law of sines, you can put the sines on the bottom or the top. I put them on the bottom if I'm looking for an unknown side, and put the sides on top. I put the sines on top if I'm looking for an unknown angle. So in this case, I'm looking for an unknown angle. So I'm going to write sine of theta, and the opposite side is 80. Equals, and then I got sine of 45 degrees is opposite 546.38. So I'm going to multiply both sides by 80. And then I basically just multiply out the right-hand side. Sine of 45, 80 times sine of 45. Divided by 546.38. All right, and then I'm going to do the sine inverse of that. It's going to be a small angle, and looking at the triangle, it should be clear why that's going to be a small angle. So 5.94 degrees. I think it's 1 decimal place. 1/10 of a degree at 1 decimal. So there's the 5.9, and of course it's west to north in both the pictures I drew. And there's the 546 miles per hour, or kilometers per hour.
Awesome. Thank you.
You bet.
Alrighty. Thank you. Have a
Okay.
good night.
Have a good night. And like I said, I'll have the video up as soon as it processes.